This video is a third sample problem for nuclear energy. So we're going to discuss nuclear binding energy problem. Now we have this equation for mass energy relations. This is postulated and created by Einstein. E is equal to mc squared, or delta E now is equal to 9 times 10 raised to 10 kilojoules per gram. So this is the speed of light squared times delta M. Delta M is for the mass of the products minus the mass of the reactants of a nuclear equation. Now let's proceed with the problem. For the radioactive decay of radium, Ra has an atomic number of 88 and a mass units of 226, decays to Rn with atomic number of 86 and a mass unit of 222, plus helium with an atomic number of 2 and a mass of 4. Now, this is actually an alpha decay of our element radium. Now, we're going to calculate the binding energy, delta E, in kilojoules when 10.2 grams of the radium decays, okay? So this is the mass of the sample, but we're not going to use this for immediate substitution for delta M. Now we are given with the following isotopes and the mass per mole. So we have the isotope for radium. Okay. The mass per mole is at 225.9771 for Rn, 220.97003, and for helium, 4.0015. Now let's proceed. We are given with this nuclear reaction equation, and radium now is the reactant, and the alpha decay conversion of radium, these are the decayed products. Now, we are given with the sample as 10.2 grams of radium-226 with its unknown delta E, or binding energy. Now we're going to proceed with our solution. First, we need to solve for delta M. Delta M is the mass of the products minus mass of the reactants. Delta M now is equal to the mass of 1 mole of helium-4 plus the mass of 1 mole of Rn-222 minus the mass of 1 mole of radium-226. Okay, so we need to solve mass per 1 mole of the reactant in this given example in grams per mole of radium-266. Now, delta M is equal to 1 mole of helium with a mass of 4.0015 grams plus 1 mole of Rn with a mass of 221.97003 grams minus 1 mole of radium 225.9771 grams. So whatever calculations we get here, okay, which is equal to negative 0.0053 grams per mole of radium-226. To further simplify this one, delta M now is equal to 10.2 grams, which is given of radium-226 multiplied with 1 mole of radium per 226 grams of radium times the one we solved earlier as negative 0.0053 grams all over per mole of radium-226. Now, this gives us with our final answer at negative 2.4 times 10 raised to negative 4 grams. Our delta A now is equal to the speed of light squared at 9 times 10 raised to 10 kilojoules per gram times negative 2.4 times 10 raised to negative 4 grams, which is our delta M, giving us with a final answer of negative 2.2 times 10 raised to 7 kilojoules as our final answer. Our next video is a second sample problem for nuclear binding energy.